Hello, I'm Nigel from Just Digital Media, and in this short film I'm going to introduce you to the digital image and explain resolution and colour depth. The digital image is a numerical representation of a subject. There are two types of digital image, raster and vector. The vector image is made from a series of coordinates that describe points and shapes in a picture. The vector image can be scaled up or down without any loss of detail. These are normally created on the computer and are used for logos and other computer-generated images. The raster image is constructed from small squares known as pixels. Each pixel has its own colour or tone. If a raster image is magnified, the pixels become obvious. A pixel-based image can describe horizontal and vertical lines with clarity. However, diagonal lines or curves have to stagger the pixel grid and result in a jagged, sawtooth line. Raster images are produced by cameras and scanners. Under normal magnifications, the raster image is quite acceptable. Under extreme magnifications, the pixels are clearly evident. Resolution is a measure of the detail in a raster image. The more pixels, the more detail. For screen use, we only need to know the number of pixels along each side of an image. For example, this is a 600 by 400 pixel image for screen use. For images destined for print, we need to know how many pixels there are per inch and how large the image will be. So a print-ready document might be described as being 10 inches by 8 inches at 300 pixels per inch. This image was captured at 100 pixels along the longest edge. A picture at this size might be used as a small thumbnail image, but if enlarged, its lack of detail is obvious. At 1000 pixels along the longest edge, the quality is significantly better and satisfactory for larger screen use. However, when we zoom in, we soon see the pixels. This slide shows a magnified area taken from an original picture, which is approximately 5500 pixels along the longest edge and is of sufficient quality to display a magnified version of the picture without revealing the pixels. An image captured effectively at this resolution should provide enough detail for printing at up to A3 in size. The simplest piece of computer data is a bit. A bit has two combinations, 1 and 0, or black and white in the case of images. If we increase the number of bits, we increase the number of colour combinations, and the quality of the image improves. The binary code used to describe a 1-bit image has only two combinations, 1 and 0, or black and white. 1-bit images are used when small file size is important, and the original object has a very simple colour palette, such as printed text or musical scores. The grayscale image is 8-bit. Each bit has two combinations, which gives 256 different tonal combinations from black to white, and is the basic bit depth for grayscale images. An 8-bit colour image has 256 colour combinations. For photographic images, this can give patchy or posterized colour. 8-bit colour images are normally used for computer graphics rather than continuous tone pictures such as photographs. The 8-bit per colour channel image has 256 shades of tone for each colour channel, blue, green and red. When combined, we get 256 to the power of 3, or 16.7 million colours. This is the minimum colour depth used for continuous tone photographic images. To get the full colour image, we need to combine all three colour channels. If we only combine two, so blue and green, blue and red, or green and red, you can see that we don't get the full colour. Combining all three, we get the full 24-bit colour image. So to sum up, a raster image has both resolution and colour depth, and it is essential that the image creator understands how these contribute to the appearance of the final image.